In this lesson, we shall identify the prime numbers up till 100 in our channel Rose Math Labs. How to identify prime numbers? What is a prime number? A prime number is a number that has only two factors, 1 and itself. In other words, it means that the number is divisible either by 1 or itself. Let's take an example. 17 is a prime number because 17 has only two factors, 1 and 17, or it is divisible by no other number except itself and 1. So let's identify all prime numbers till 100 by a very simple method. Let's identify prime numbers below 100 using the sieve of Eratosthenes. We have a grid of numbers 1 to 100. The number 1 is missing in the grid, as we know 1 is not prime because 1 has only one factor, that is 1. We have already defined a prime number as a number having two factors, 1 and itself. So the first prime number is the number 2. Also 2 is the only even number that is prime. So 2 has only two factors, 1 and 2. So 2 is the first prime number. We will leave the number 2 and we will color all multiples of 2. Or in other words, we will shade all the even numbers except 2. So all the multiples of 2 are colored in blue. But 2 is not colored as 2 is a prime number. Now we go to the next number in our grid, that is number 3. 3 is also a prime number as 3 has only two factors, 1 and 3. So we will not color 3 and we will color all the multiples of 3. Here you can see we have colored all the multiples of 3. Some before were already colored as multiples of 2. So we have shaded all multiples of 2 and 3 except 2 and 3. Then comes the number 4. 4 is already colored because 4 is an even number and is a multiple of 2. Hence 4 is not prime as it has more than two factors. Next comes the number 5. Yes, 5 is a prime number as it has only two factors, 1 and 5. So we just leave 5 and we color all the multiples of 5. Now you can see all the multiples of 2, 3 and 5 are colored. Next comes the number 6, which is already colored because it's a multiple of 2 and 3 and hence it is not prime. Next is number 7. 7 is also prime as 7 has only two factors, 1 and itself. So we leave 7 and we color all the multiples of 7. Next is number 8, 9, 10, which are all colored. Hence they are not prime, having more than two factors. Followed by the number 11. So we leave 11 and color all multiples of 11. But all the multiples of 11 are already been colored or crossed out. So we are done with. The numbers which are not colored are our prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. Wasn't it an easy method to find out the prime numbers till 100? So here we see all the prime numbers up till 100. You can see there are altogether 25 prime numbers. Do not forget the sieve of Eratosthenes to find or identify prime numbers.